Hello Earth, welcome to episode 45 of season 2 of Making Cell, a series of videos where I record myself designing and implementing a programming environment called Cell. So if you're just tuning in for the first time, please, I recommend you go to github.com/autocolonel/cell. Link is in the description. So we are actually making slow but good progress. And I think the season should be over very soon, because 45 episodes is quite a bit. Oops. So I just pasted the description there. So we're annotating the source code for Cell, the new things I implemented in the last couple episodes. We're just going to continue doing that. We actually found a bug yesterday. We finished annotating the stripper function, so we can get rid of these. Do we have one for current expansion here? No, I suspected it. No. So we want to move. Really define the output. Where do we need output? We need it down there. It's okay that we define it at the top. I think it's fine. These ones I want to bring down here. This goes away, really. Yeah. Yeah. So we're gonna... Did we explain? Yesterday we were trying to explain what we were doing, right? Or we did it already. Yeah, we wrote it here. We consider the message to be a sort of step 0 of the definition. Yeah. We write the function, we run each of the steps, do a stripper and compare them to the definition. If it stops, you stop. If not, you keep on going. If you make it all the way to the end, or a stopping value, or find a stopping value, stop or error, we have a response, so we just return output. Before this we have output, right? Yeah, perfect. So we have this terminology that I'm not really happy. You have the current versus... What did we do when Cell respond with those names? Because... yeah, we're like completely changing the terminology, because we have the previous value and the current value. So I want to use that, right? So what I'm calling the current expansion is really the previous expansion, the one that was there before. And the current message is that one. Still works, right? Yes, good. And the message, yeah. And what I'm calling the current value here, I guess could just be the value. But it's okay. We're gonna leave it as is. This already is better, much better. We get the previous message by getting the what's currently at context path plus colon, and removing everything from it, removing let's say sick from it. Expansion. From there we remove and just get the current, sorry, the previous message. We compare the previous message, stripped previous message, with the stripped message we received as an argument. If they are not the same, we will update it. Actually, we can do this here. This one we can close. It's yesterday's. What was that actually? Oh yeah. If they are not the same, that means that the message name or its value changed. We will then set context path plus colon to the new message. We do this through a direct call to cell put. We then return output, which will be a single path with an empty text, and close the case where the message has changed. Actually, this can that can be because of two reasons. This is the first time that this call is being executed. The message name or its value changed. In both cases, the required action is the same. Excuse me. And then we'll return our output. Nice. Okay, so a bit more clear, right? It's also the initialization. If we are here, we're ready to look at the what's. of the steps of the sequence. We start by stripping the first step out of the paths of the definition, since they are all the message name, right? That was the message name we're stripping, for which we no longer have use. Do we? No. Just a minute. Alright, I'm back. So yeah, we have no use for the message name because it's already in the definition, and the definition knows what to do, and things get resolved by get, so that's fine. Yeah, I think this is coming out right. Sequence length, yeah, we do it, use it twice, right? Yeah. So yeah, we also know the length of the sequence. We are ready to, this should go away, to start iterating the steps of the sequence. We will iterate up to n times, where n is the length of the sequence. We will stop. Can make this a return true. Untrue. All right. If we get true, we'll use true as a way to break out of the loop early. Here we need to go with the same previous step and current step, right? Yeah. I want to understand this is literal. Actually, we can get that. We can get there later. Okay, let's annotate. Come on. The previous step is the step already stored at context path plus colon sequence step number. It's previous in the same way we earlier refer to previous expansion and versus current expansion, not as in step n-1. We also get the current step from the definition, slicing the number from the front. Yeah. As with the message, we compare the previous step and the current step, and if they differ, we set the current step at context path plus colon sequence step number. Ah, look, we just returned here. So this is wrong. For some reason it still works. Yeah, because our tests are too simple. I need to test a lot of cases when this works. Anything that's not we are returning, that in the case conditional above, body of the conditional, we're returning the result of cell put, which will stop the loop early because it's not undefined. Nice. I know what I'm doing here. Flor, este planeta de arena. We'll now get the value of this step. This is a bit trickier. That's not so tricky. To do this, we need to see if the value of the step contains a call. If it does, concatenate equal to its path, so we can get the proper value. If it doesn't, the step over itself is the value. Dun, 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 dun. I am tempted to do this some other way, like this, for example. But now it's going to be a mess, right? Nah, this is okay. Yeah, we could do it like this, right? Yeah, slightly less clear, but more elegant. Whoops. How can I break things so easily? All right. Yeah. If I do it like that, it also works, right? If I of course, we would have to undo. It's not undo it, but negate it. Dun, 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 like this. Much better. All right. Actually, let me change the record. I'll be right back. All right. So we have this, and exactly, if we have no value yet, we give up and come on later. If there's no value yet, because the call hasn't been expanded, just give up by returning true and come back later. I like it. I like it. I like it. I like it. I hope daily that this is a living structure. So if we find a stopping value, an error, or a stop, or we are at, sorry, if we're here, there's an existing value already. If that existing value is a stopping value, a hash with a key error or stop, or we are at the last step of the sequence, we set output to existing value, we also return true to stop the sequence. We don't really need to return true if we are at the last step of the sequence, but since we are using a joint conditional to detect to do the same if we find a stopping value, we just return true always anyway. Wow, we're done with this. We close the iteration over the steps of the sequence, return output, and close the function. Nice, really nice. Okay, before we get too excited, we need to do another pass on this one because I think we might have changed it. Not here. There's space dot mode. Oh, it feels such a long time ago that I wrote this stuff. A lot of dog ears here. Oh, but this is the same. I didn't change yet. Matches. Yeah. Context path. Let me just be careful here. This that we're doing here is pure investment. Yeah, look at that. Matches and yeah, cell put. I'm sure it changed. I like how I say whopping 5 arguments, and then we had functions with 6 already. So top level keys. This is same. Left side, right side. Yeah. The validation. It's not such a big function. It's pretty cool. Wait, we're getting the data space here, right? Sorry, I missed something here. The left side 1 for sure. Then we have left side 0. And then we have the forbidding of yeah, no, it was fine. Dialogue. And then this one. Yeah, this is all the same. Yeah, this is all the same. I'm glad I annotated this stuff because it's not so easy to follow. Run the sorter. It's almost all the same. And here the only difference is we're wrapping this in a loop. Running cell respond on each of the paths until either finish iterating the paths or cell respond returns true. We call cell respond in case some reference needs to be updated. If cell response has, it will call cell put in turn. The true that cell respond is a mere is only to make things more efficient and avoid unnecessary calls. This is still true about not validating, but I'm putting a lot of faith on my own validation, which I should anyway. Okay, it's really annotated now. Well, I'm missing a bunch of functions that I put to do, but like the tough ones are annotated. Well, not that stuff. Yeah, so we did order, sorter, path to text. Validator is definitely a good candidate to annotate. Do I do it now? No, I just want to keep on going. Sorry. I'm gonna be bad. So let's just take some stock. Where are we? We are we need to make the sum work. How? Well, we need to make plus work. Maybe we should commit, right, before breaking through other things. Yeah. The pretty function is too pretty to remove. I can remove these comments here and this one here. So how much is it? Okay, 80 lines. Yeah, it's okay. Yeah, we have quite a good validation there too. It's pretty good. Now if it could be useful. Yeah, let's commit. Cell do and cell response fully annotated. So now what? Now, what do we do with the plus? We want to let users override the plus if they want to. Let users override plus if they want to. I mean, with do it would be different, I guess, because we're doing it globally, because otherwise how you would define something if you're overwriting the definition mechanism yourself. But with plus, yeah. let's definitely let them do it. Let ourselves do it, because I'm also going to be using this stuff. I sure hope. Man. So, I had this idea sometime. I was just walking around, and I was thinking that the place to add a, like a native call, once you don't find it in the data space, it would be here. Actually, not there. It would be here. So the current value is nothing. So you try to get it in user space walking up. Well, not walking up really, just trying the different combinations of left side and right side. And if that doesn't work, you can try here. So I want to do this. What if I do that? What if I do this? If path index of, we could do something like plus. Okay, that seemed to work. We are starting to get somewhere. We have two problems, but we have it. This is the right place to do it. Problem is that this call to plus, there's two problems. Let's just write them down. We need to do two things. Get multiple lines, paths to the same call. Ideally, get the first one and ignore the other ones. There's no way around it. I cannot do it the way I did it before, with like expanding things one at a time, because it is a batch. We need them all like at once. Boom. It's different. I get multiple. To when you are looking at the first path of a call with multiple paths, get all those values and pass them. If you are at the second path or further, multiple paths don't do anything. And then make plus call the JavaScript function. So how do I know if I'm in the first one? I mean, if it's a list, it would be 1. If it's a list, just check for 1. But no, it could also be 1 full and 1 bar. And it could be a hash. I know how to do it. Okay, we can do a look behind. The paths are sorted. Sorted, not stored. Interesting that those are anagrams. Sorted and stored. Yeah. Join us. Fighting for. Oh. So it's like the look ahead we did in the stripper. I like how the patterns are repeating, but it's not the same. It's like subtle. Nice. You can do a look behind. The paths are sorted. If you don't find an earlier one, go for it. If you do, stop. Don't do anything. Nice, nice, nice. I really like this. So let's do the look behind. But how do we know if we can do the look behind? We can do like native calls. We can do plus minus times divided and what? Fighting for, and then modulo, right? We can also do greater than, less than. Right? We could do that. It's comparison. And the equality is going to be EQ, right? So we have the native calls would be I'm concatenating this. I'm going to do it in several ones. Maybe I can do it like this. Can I do multiple concat? Yeah, you can. Nice. Math. This is and comparison would be equal. I guess we can actually do not equal, although we will have the no. Comparison. And then logic, right, would be and or not. I guess, like how these decisions can come out from a whim, we can do greater than or not, or less than. No, because these are mathematical and these ones are, well, it's also mathematical. But no, let's do it like this. Logical. Yeah. I can do it like this. I'll just stop, iterate me this. Stop not undefined. So if the path is greater than this, return the call. All right, it's working. I'm getting excited. So we have a prefix here. The prefix would be, and this has an at, right? So I know we're doing them one at a time. No, I need to know. Yeah, but it's done on the, yeah, I'm already going right to left. I'm already doing everything that I need to do, I think. The test will prove me wrong in time. So we have a 9. You can actually go quite far with this stuff, right? Yeah. But this should be really at index 0, right? Yeah. Yeah. So there's no need to do this actually. Sorry. As a good friend told me once. Sorry, not sorry. Hi, Jess. If actually could do it like this, right? Honestly. Six, 5, 3. Wow. Why am I so slow to sum? 14 operations, right? 6, 5, 3, yeah. 14. Not bad. So around 20 words. 20 calls, sorry. Words is fourth. Calls is L. good. I would love to have a powerful language with 64 calls. 64 is the power of 8, right? Of 2? 2, 4, 8, 16, 32. No, it's the power of 5. Nice. We have 5 pillars in Toddy, so why not? 2 to the power of 5. If value path 0 actually native calls index of, and yes, I'm gonna make this Internet 6 Explorer 6 compatible, so I definitely want it to be all JavaScript. Good. And now we do the prefix. I would take the I would do all the paths. But I don't have all the paths. Ah, that's a problem. That's a problem. I don't have all the paths. I'm just looking at them one by one. Don't I? I do. Why are you doing this to me? What do I do? Can I pass all the paths to start respond? Yeah, let's just do that. I mean, I could just get paths, right? Like get them all, which is horrible, but in some way cleaner. Okay. Efficiency will come another day. So I'm getting all the paths, so I basically would I can even just but I wanted to do it backwards. But to do it backwards I need to, no, this is too much. At least I need to pass. It's just offending me to make it so inefficient. To have to search for yourself. It will be like a linear search from the top. No, I'm okay with making it inefficiently. I'm okay with it. I'm okay. And we compare the whole thing. You would take path slice 0 to k, you reverse them to start with the other ones. tab. If b slice, so the value path is everything to the right most, so it's the target path we're getting, right? Yeah, it will be the rightmost at minus the equal it would prefix target path slice, chop off the last one, and then you do at, right? And then the actual native call. Yeah. I'm not sure if it's +1 or not there. We'll find out soon enough. Equals to yeah, compare that to the prefix exactly. Not first pass. It would be this true stops, and then we get, yeah, it will work. Let's see. Okay, the prefix is correct. Ah, that was it. Wow, it did work. It really worked. Wait, 1 1. No, it's not working because it's, wait. No, it's not working because I see that this one should not be there. But to gather all the other paths, I also need to look forward, right? Yeah. Not sure if I want to hear this now. Maybe this one, yeah. Where's the case where I have a second one? I want to see that the case where I have the two, I'm comparing. Okay, this is correct. So length of 5. Yeah. This one is the one that's wrong. I have all of this. The prefix removes this. It's comparing against. Yeah, this one. Why is it there? 1, 2, 3, 4, 5. It's the plus one that screwed it, I think. Yeah, that's what's wrong. Uh-oh. What I need to do is if the length also no. Thank you. Why does it keep on iterating? It's never setting a value, I guess, right? Why? Okay, we're gonna leave this mystery for tomorrow. Thank you for watching.